Hello friends, let's continue our discussion on MaxFlow MinCut. This is one technique which is useful to many applications, and the whole idea behind this problem is to identify sensitive edges that need to be protected with a high vigilance and all that. So there are two ways of solving this. One is either finding the cuts so that the source, which is node 0 here, and the target, which is node 5 here, are disconnected. So there are many ways to disconnect them, and so finding all possible ways becomes difficult because we may miss some of the ways, and may be unfortunate that the one which we forgot may be the best solution. So it makes sense not to go into MinCut, but go to MaxFlow, because it has got a limited activities to perform, and we are sure that we have done all the activities in that. When we stop, we are 100% sure that we have done everything expected to do. So MaxFlow is a better version of solving this problem. So let's begin our journey. So the MaxFlow is a method wherein we try to find the path from the source to destination and then prepare the residual graph, that is the one which is still remaining after that is used. Okay, let's begin. So it may be this route. So that means you go from 0, then go to 1, then go to 3, then finally go to 5. In this, what is minimum? Minimum is 12. So if you consider this as a speed of the internet, 12 packets per second, 16 packets per second, 20 packets per second, if that is the thing, then the whole flow is possible at maximum of 12 packets per second only, can't be more than that, because the edge between 1 and 3 is not able to allow more than 12 packets per second. Therefore, from 0 to 5 through this path, it can take only maximum 12. Okay, that's what we can talk of. So when 12 has gone, then nothing is remaining here, and here the total capacity was 16. Now 4 have gone, 12 have gone, so 4 more are remaining, and this was 20, so 12 have gone, so 8 more are remaining. Okay, that's one way of working. Okay, next, any other path? Yeah, we can go from 0 to 2, 2 to 4, 4 to 5, direct path. Yes, we can take up. Right, so that is 0 to 2, 2 to 4, 4 to 5, and in this you can see that 4 is the minimum. And because this whole path is under control of 4 to 5 link, and this is going to allow maximum 4 packets per second, therefore 2 to 4 also should allow maximum 4, and 0 to 2 also allow maximum 4. That means out of 14, 4 have gone, so 10 more are remaining for some other usage. What else? So there is 9 remaining here, there is 10 remaining here, there is 4 remaining here, So if we come to this, then these four you can take up through this. Okay, from 1 0 to 1, 1 to 2, 2 to 4, 0 to 1, 1 to 2, 2 to 4. From 4 you cannot go to 5. Therefore, what you can do is you can take this path 0 to 1, 1 to 2, 2 to 4, 4 to 3, and this way. So in this route, we have a possibility of 4 here, and we have 10 here, then we have 10 left here, then we have 7 here, and then we have 8 here. So 4, 10, 10, 7, 8. So minimum happens to be the 4. So that's gone. So we are left with 6 here. Then we are left with 6 here. Then we are left with 3 here. And then we are left with 4 here. Okay. Then what else we can do? So this has become 0. So from source there is no chance of going to 1 again. So now only thing is you can look for what happens if we go to 2. If we go to 2, from 2 you can go to 1, but from 1 there is no outward possibility, because whatever path we have, it's already full. Therefore going to 1 is not possible. Then going to 4 is possible. From 4 you cannot go to 5, but from 4, yes, you can go to 3, because 3 more packet size is left there, and from 3 to 5, 4 more is left. So what was this path we had worked on? 0 to 1, 1 to 2, 2 to 4, 4 to 3, and 3 to 5, and this was 4. Okay, what next? Next, yeah, we can go to 2. Then from 2 we can go to 4. From 4 we can't go to 5, therefore we have to go to 3, and from 3 we should go to 5. So 0 to 2 the size is 9, 2 to 4 it is 6, 4 to 3 it is 3 left, and 3 to 5 4 is left. So the smallest possible thing is 3. Therefore we say that 0 to 2, 2 to 4, 4 to 3, 3 to 5, we have 3 left. So that becomes 0. And if 3 goes, 6 remains here, 3 goes, 3 remains here, and 3 goes, 1 remain here. So anyway, 1 can we get? So what are the, from this way not possible, this way 6 is there, then you can go up but cannot continue further. Then you can go back to 4 again, 3 are still there, but once you go to 4, either you have to go to 3, no path is available, or go to 5, no path is available. Yeah, that's it. I don't think anything else is possible. Okay, now what this new route says, so nothing is available. So that is 16, 20, 23 is the answer. Now let me remove all old cases and retain only the fresh values. So that's it. Okay. So now looking at this, totally we had 4 paths, and from 4 paths we found 4 zeros, and 4 are the what do you say, links which are sensitive. So how does that work? I think it works something like this. Okay. So there's a this is our mean cut, and that's going to provide a total of 23, and we say that our sensitive edges are 0 to 1, that is for this 0, 1 to 3 for this 0, and 4 to 3 for this 0, and 4 to 5 for this 0. So these are the 4 edges which are sensitive. So this is going to tell that I don't think this cut is needed, this cut is sufficient. So we can say that this cut is sufficient to divide that, and I think 0 to 1 may not be a sensitive edge. Okay, anyway, if you look at it, then this is what we get it. Now we need to look at why 0 to 1 is not a sensitive edge. We can just check that. What can we do is we'll begin our activity again. So we're there. This was 12, this was 20, this was 16, this was 13, this was 14, this was a 4, and this was a 7, and there was a 10 here. So our first one, 135, so that makes it 4 here, 0 here, and 8 here. Then 245, so that makes 0 here, that makes 10 here, that makes a 9 here. Done. Then this 10, 9, 7, 8, if you look at it, so we can take up one direct link, that is 0 to 2, 2 to 5, 5 to 3, and 0 to 2, 2 to 4, 4 to 3, 3 to 5. This one. If we take this one, then what is minimum here is minimum is 7. So these two together it becomes a 7. So unnecessarily we had split this into two parts by taking a wrong path. Anyway, so this if you take it 0 to 2, 2 to 4, 4 to 3, 3 to 5, then 7 is minimum, then this becomes 0. There is a 1 here, and that is 3, and this is going to be 2. Anything else? So from 4 you cannot continue because both the outward journeys are 0. From 1 you cannot go to 3 because that is 0. Then what else? A 2 is remaining here. What should I do with this 2? I have to send it to 4. From 4 I can't move further. Or these 2 packets I can send to 1. From 1 I cannot send further. Or these 4 packets are still residue. So if I try to use this, then it goes to 1. From 1 it can't go to 3, so I can go to 2. From 2 I have to go to 4. From 4 outward journey is not possible, so this I cannot take up. So that's it. So only these 3 are required. This is not required. So that total again makes 23. So this is 0, this is 0, this is 0. So that's a cut. Yeah, now we got a correct one. This is one unnecessarily taken up. So it says these are the 3 important edges which need to be taken more care. So if you want to maintain maximum flow, then make sure that these 3 edges are well maintained with good health, so that our network will provide a maximum flow and give better efficiency and all that. So that's another example we solved for finding the maximum flow rate. That's 23, and this is the minimum cut, and these are the 3 sensitive edges. So it gets all 3 answers. What is the maximum flow possible in this from source to destination? That is 23 packets per second. So what is the min cut? Yes, this is the most sensitive cut that's going to disturb our network to its maximum. Then what are the sensitive edges we have in our network, so that we need to give more attention to these edges. So these are the 3 questions we needed to find the answer, and we found them. So that's how MaxFlow MinCut logic helps in solving most of our networking problems. So be it a computer network, be it a road traffic, or be it any such issue. So this algorithm comes handy in solving the MaxFlow MinCut sensitive routes, sensitive edges, and all such things. So that's it for now. Thank you. Keep watching for many such issues. Thank you.